Hello, this is Mr. Reynolds, and I just wanted to give you a heads up on the videos that you're doing. You're looking at this introductory one, and then you're going to see a heart dissection one, and then you're going to see a number of, you're going to see a third video with a number of slides in there that's mainly some introduction stuff to circulatory system. So you just finished, we just did some stuff with the heart, and I think you did some coloring of the answered questions, did some coloring of it, and we wanted to see a heart dissection. So that will be coming up very, very shortly. We've got 6 slides here. Okay, so like I said, we're reviewing some structures of the heart and maybe a little bit of introduction to circulatory system today. Structures of the heart. Remember a lot of these from the other day. Ones that you'll see okay on the dissection. I already did that. It wasn't. It was okay, but you could see some. You could see different muscle fiber. We could see the papillary muscles pretty well, and then the chordae tendineae, that attach to these pupillary muscles, okay, and attach to some of the valves. Right ventricle, I'm sorry, right between the right atrium and right ventricle is tricuspid valve. Between the left atrium that gets blood back from the lungs and the left ventricle that's going to pump it out to the rest of the body through the atrium. The valve between these two, between the left atrium and left ventricle, is the bicuspid or mitral valve. Blood, when it's pumped from the ventricles out, in this case out to the lungs, these are semilunar valves, or from the left ventricle out the aorta, aortic semilunar valves. And notice the aorta will do a 180 very, very quickly, become descending aorta. It's going to have 1, 2, 3 main branches coming off. The inferior vena cava brings blood back to the heart. Superior vena cava brings it from above back to the heart. They both enter in the right atrium. The next slide will show these a little bit more. This interventricular septum will become a little bit more important when we're doing conduction of the heart. Moving in the conduction of the heart that we'll have next, I'm going to change color here. We're going to have the sinoatrial node up here. It's going to send fibers out, so this right atrium and left atrium contract at pretty much the same time. Not exactly, but very, very close. Then as the impulse goes down to the AV node, it's slowed down here a little bit. It's got all these nerve fibers to go through, so even 1/10 of a second, 2/10 of a second. It gives the atrium contracting time to pump the blood into the ventricles. They fill up, and then we get contraction going on as the fibers, basically they look like nerve fibers. They very much look like nerve fibers. This is going through bundle of His. This is becoming Purkinje fiber. Purkinje fibers up here, and those branch off into muscles, and that's what makes the ventricles pretty much both of them contract at the same time after they're filled up. Okay, we need a little bit of time from when the atria contract and pump blood down into the ventricles. It needs to be a little bit of time. As ventricles are filling up, then they're filled, then they can contract. So we can't have the atria and ventricles contracting at the same time. So this next slide gets into just a review of the conduction of the heart a little bit. Okay, like I said, up here at the top we have the SA node, gives off fibers to the right atrium, then over to the left atrium. Those contract, pumping blood down into their respective vesicles. Okay, respective ventricles. I'm sorry. So the right ventricle, left ventricle. Left ventricle, I said, remember, pumps blood to the rest of the body. There's a slight decay in it. All right, AV bundle coming down here from, again, sinoatrial node to the AV node to the atrioventricular bundle. Branches off to Purkinje fibers as they come down, and they surround each of the ventricles, giving off fibers themselves. Again, remember, this is what's amazing, this is all modified muscle tissue. Even these things that look like nerves, they're not nerves. They conduct like nerves, but it's muscle tissue in origin. This inside of the heart that you had to color the other day, I think you colored the pericardium, the myocardium, and I'm sorry, pericardium was outside, endocardium inside, endocardium, myocardium, pericardium. This endocardium, it's not endothelial tissue. It looks like it, but it's not. It's modified muscle tissue. The entire heart is. That's kind of amazing. Okay, next slide. So actually, so once it's pumped out the aorta, which it doesn't show here, well, let's give it a good red aorta. Okay, good red aorta that takes a nosedive and becomes descending aorta. You can see back behind the heart, then it branches off to all different types of organs that we'll see in a minute as it goes down, then it branches off to each of the legs. Up here at the top, we're going to see 3 main branches coming off. Okay, probably this one would be going over to the right arm. This would be going to the left arm. This is going up to the brain. Okay, so we'll take a look at those next. As the blood comes out of the heart, it's going to go to all different tissues in the body, including the little toe, including the top of the scalp. All right. Then it's going to go through little capillaries and it's make its way back to the heart through the venous system. Okay. Not much blood pressure here. So as it's coming out in arteries, that's one thing we'll teach today. Then we'll see some arterioles that'll be labeled. Capillaries, the smallest blood vessels in the body. As it's starting to make its way back, these would be venules, spelled a little bit differently. Venules. Larger structures, veins, back to the heart, close to the heart. We're getting into those 2 vena cavas, and then it's in the heart. Okay, I'm going to write the word arterial over here. It makes me feel better. Okay. This is where the capillary is where the gases are exchanged. Usually oxygen is given off, going to the tissues that need it. And as they were working, they built up carbon dioxide. Once the hemoglobin in the blood drops off oxygen, its side is free. Then it picks up the CO2. Most people don't get that. Okay, carries it back up to the veins and to the heart. All right, here's just another look at all the organs that have to be supplied. Right now we're seeing the blue veins, but there's going to be, you'll see another slide later where it's going to have the arteries, showing all the arteries coming down and giving blood off to these things, giving blood off to all these organs that have to have it. So then the blood comes back to the heart from it. You can see in these vessels right here, as it's branched off, these are getting ready to go down to the legs, okay? I think this is the an iliac vein. Iliac, that's we're in lower back still, and then branches off, and we're heading down to the legs. Okay.